Okay, let's get into it. So today I'm gonna try to I think I am signed in. Guess not. Okay. So I think a couple days ago we did this. I just did the extrusion, so we or the sweep. So we were at here. So what we were able to do is take two arbitrary points in space. How that was done was first you make an offset plane of one of the three coordinates, and then you just make the other two and then so this point is point A, which is, you can see here, one. Oh, I actually messed this up. But I mean, it doesn't matter. 1, 2, 3, and then this is -3. And yeah, see, again, I did this wrong. So this sketch is 6 on Y and 4 on Z. I mean, it doesn't really matter. It doesn't change any of the geometry or whatever. But just to make sure that it's right. So then we make a plane that's tangent to, and how did we actually do this? Point normal. Okay, cool. So there's just a normal. This is the same as the edge normal that we saw in FreeCAD 2 days ago. So that's good. Now, one thing is they have this thing, and we looked at this a little bit ago, is that you can just do a show code. And this shows the entire representation. But the thing is, you see here, there's so much obfuscated stuff here. But anyways, the plan, and so I was able to upload JSON, and I was able to say featurescript JSON and find this, which is parse a JSON in string. Let's see, if we just go to this, is there a search? We'll do the tutorials for sure, just because I do want to like know this as a real thing and not just because the thing is, for FreeCAD, I don't know. I didn't really care, but I actually do feel like knowing featurescript might be kind of cool. Oh, wow. Wow. Oh, that's so cool. What's the license on it? MIT licensed. That's pretty sweet. Okay, let's okay, and I guess I should say this too. I mean, not that anyone freaking watches these, but the goal is to recreate this paper. So let me just open up VS Code, so we have our notes. And so the paper is this. I thought I had it. I did at one point have it. I think it's just in my. It's whatever. I like reading these. Oh, wow. Dude, I gotta get my Copilot back. I haven't had Copilot in like 2 weeks. Oh, that's so cool. That's so cool. Public code matching in chat. I've never really tried any of this stuff out. That's so cool. What does this function even do? I mean, that's so cool. I mean, the dream of just being able to talk and then have stuff show up on the screen is so great. Okay, I think we're good. All right. So, yeah, so it's this paper. Oh wait, it's going to open in the wrong place. Okay. Oh, wow. Oh my god. Oh my gosh, mold design? Oh, wow. This is really cool. Dude, I didn't know about any of this. That is so rad. I didn't know about that at all. Whoa. Dude, actually, though, that's sick. That's fucking sick. How does it work? Dude, that's so cool. Dude, these are so sick. Dude, yeah. Actually having, wow. This custom feature creates a hardware boss. I don't really... See that? Okay, see, that seems like what we want. We don't want it to be a spline, we want it to be a line. So wait, hold on. Move face? What is move face? You can't change any of this? Okay, I feel like... Okay, but I feel like this will be useful just to figure out how to make a vertex at a global point, you know, with reference to the global geometry. See, I wonder how this is specified. Snap hook. I've wanted to do so much about compliant snapping together because, dude, these people make such aesthetic videos on Instagram, and I want to be able to do that. It's funny because they like, whatever. It's just funny. Okay, let's just go through the tutorials now. Now that I want to look at the rest of these. Oh, that's cool. Where does that face come from, though? No, this is the feature. Wait, what? What is this? Oh, airfoil. Wait, did we look at the mold design one? That's so cool. Right, so that came from elsewhere. These demos are so cool. Okay, it's time to get started.
From any Onshape document, you can click the plus button and create a new Feature Studio. A Feature Studio is an Onshape tab designed for writing and editing featurescript. To create a new feature type definition, press the New Feature button. This will insert some template code necessary for creating your own feature type. The parts of this code that you'll likely want to change are contained in a few autocomplete regions. You'll start out highlighting the first of these regions, and you can navigate to the next region by pressing Tab, or the previous region by pressing Shift-Tab. I'm going to start out by changing the externally facing and the internally facing names of this feature type both to slot, and then tab to the precondition, where I can define some feature type parameters. One thing you'll see as you type in a Feature Studio is an autocomplete menu. This will give you some suggestions of featurescript that you can insert based on your code context and what you're typing. These autocompletions also contain regions that you can tab through. Here, I'll define a query parameter that takes in geometry from Part Studio that I'll use later to define the path of this slot feature. My next parameter will be another query for a part in the Part Studio, which will end up being the part that we cut the slot out of. And the final parameter will be a one-dimensional length that we'll use as the width of the slot. Now, at this point, all my changes are saved within Onshape. However, they're not visible yet to other Onshape tabs because I haven't committed. You can always tell when a Feature Studio has uncommitted changes because there will be an asterisk on its tab right before its name. To commit a Feature Studio and make it visible to other tabs, press the Commit button. Now it's time to move to the Part Studio, which I'm going to open in a new tab and move that tab to a new browser window just to keep everything visible. To test out the feature, I'll make some new geometry by sketching a rectangle and a few internal lines that will eventually become slots with this slot feature. I'll then extrude the part to something that could be a laser cut part, and now it's time to insert the slot feature. Hit the featurescript menu, and then you'll see all of the features defined in Feature Studio 1. You can see the Part Studio has detected our feature and named it slot, which comes from the feature type name defined over in the Feature Studio. When you click on slot, it will insert a feature named slot1 and bring up a feature dialog according to what you defined in the precondition. So you can see we have two query parameters, one for the slot path and one for the part to cut, and one length dimension for the slot width. Now, one interesting thing to notice is that for the part to cut parameter, we can only select this length slot path. See, we have two according to feature named slot1 and bring up a feature dialog according to what you defined in the precondition. So you can see we have two query parameters, one for the slot path and one for the part to cut.
We got crows.
slot, which comes from the feature type RStudio menu, and then you'll see all of the features defined in Feature Studio 1. You can see the Part Studio has detected our feature and named it slot, which comes from the feature type name defined over in the Feature Studio. When you click on slot, it will insert a feature named slot 1 and bring up a feature dialog according to what you defined in the precondition. So you can see we have two query parameters, one for the slot path and one for the part to cut, and one length dimension for the slot width. Now, one interesting thing to notice is that for the part to cut parameter, we can only select full solid bodies, and for the path parameter, we can only select edges. This is the effect of setting this filter field over in the Feature Studio for these two query parameters. When I set the slot width over here to 3 millimeters, Onshape's going to translate that into my default units.
Dude, this is so sick.
Just like in any other feature. Now it's time to define the feature's behavior. We'll do that in this second code block here, right after the parameters.
I wonder if I can select a file, though. Because we need to be able to read in... I think it'll be fine.
We'll begin by extruding the slot path, so type extrude and change the entities to definition.slotPath, which is the name that we defined in the precondition above. We'll change the bounding type of the extrude to through all, and since a through all extrude doesn't need a depth, we'll get rid of that parameter, but instead specify that the body type of this extrude needs to be a surface. To update the other tabs with these changes, press Commit, or press Ctrl-S or Command-S. Since our Part Studio has an instance of this feature type, we immediately see it update with the extrusion. Our next operation will thicken this surface. In our Part Studio, type opThicken and insert the autocompletion, and for the entities, we'll query for the geometry created by this extrude using a queryCreatedBy and passing in the extrude's ID. For the thickness, we'll make this a symmetric thicken by passing in half the slot width to each of the thicken directions. Commit your Feature Studio to see the operation take effect. The opThicken created a new thickened part in our Part Studio, but it also left behind the old surface, which you can see in the parts list. To clean this up, we can use featurescript to delete the body. Type and insert a call to opDeleteBodies, and for the entities, pass in the same query for the surface body created by our first extrude. When you commit this change, you'll see the extruded surface disappear. Finally, we'll subtract our thickened part from the given part to cut with an opBoolean. For the tools, we'll use another queryCreatedBy, this time for the body created by our thicken operation. For the targets, we'll pass in the definition's part to cut that we defined earlier, and for the operation type, set it to subtraction. When you commit the operation, the part will be subtracted. And that's it. We've now completed a new custom feature type. When you update the parameters to...
Alright, so now that I've watched it, I'm going to do it. Okay, so... Okay, so let's just watch it again.
From any Onshape document, you can click the plus button and create a new Feature Studio. A Feature Studio is an Onshape tab designed for writing and editing featurescript. To create a new feature type definition, press the New Feature button. This will insert some template code necessary for creating your own feature type. The parts of this code that you'll likely want to change are contained in a few autocomplete regions. You'll start out highlighting the first of these regions, and you can navigate to the next region by pressing Tab, or the previous region by pressing Shift-Tab. I'm going to start out by changing the externally facing and the internally facing names of this feature type both to slot, and then tab to the precondition, where I can define some feature type parameters. One thing you'll see as you type in a Feature Studio is an autocomplete menu. This will give you some suggestions of featurescript that you can insert based on your code context and what you're typing. These auto-completions also contain regions that you can tab through. Here, I'll define a query parameter that takes in geometry from Part Studio that I'll use later.
Query parameter? Okay, so we just type in query parameter. And then
your codes also contain regions that you can tab through. Here, I'll define a query parameter that takes in geometry from Part Studio that I'll use later to define the.
Okay. Okay, cool. So slot path edge. Oh, what? It's kind of weird. Edge. Oh, you push enter, but then the tab dies. Okay, whatever. That's okay.
Path of this slot feature. My next parameter will be another query for a part in the Part Studio, which will end up being the part that we cut the slot out of, and the final parameter will be a one-dimensional length.
Okay. So this is going to be any typed up body and body type. Oh, that's so annoying. What was it? Solid? And this is part to cut. Cool, this is pretty straightforward. Another query parameter. And what is this?
That we'll use as.
Wait, he did something different here.
Part that we cut the slot out of, and the final parameter will be a one-dimensional length that we'll use.
Oh, okay, so they just have a, yeah, because it's so common.
Use as the width of the slot. Now, at this point, all my changes are saved within Onshape. However, they're not visible yet to other Onshape tabs because I haven't committed. You can always tell when a Feature Studio has uncommitted changes because there will be an asterisk on its tab right before its name. To commit a Feature Studio and make it visible to other tabs, press the Commit button. Now it's time to move to the Part Studio, which I'm going to open in a new tab and move that tab to a new browser window just to keep everything visible. To test out the feature, I'll make some new geometry by sketching a rectangle and a few internal lines that will eventually become slots with this slot feature. I'll then extrude the part to something that could be a laser cut part, and now it's time to insert the slot feature. Hit the featurescript menu.
That's pretty nice.
And then you'll see all of the features defined in Feature Studio 1. You can see the Part Studio has detected our feature and named it slot, which comes from the feature type name defined over in the Feature Studio. When you click on slot, it will insert a feature named slot1 and bring up a feature dialog according to what you defined in the precondition. So you can see we have two query parameters, one for the slot path and one for the part to cut, and one length dimension for the slot width. Now, one interesting thing to notice is that for the part to cut parameter, we can only select full solid bodies, and for the path parameter, we can only select edges. This is the effect of setting this filter field over in the Feature Studio for these two query parameters. When I set the slot width over here to 3 millimeters, Onshape's going to translate that into my default units, just like in any other feature. Now it's time to define the feature's behavior. We'll do that in this second code block here, right after the parameters. We'll begin by extruding the slot path, so type extrude and change the entities to definition.slotPath, which is the name that we defined in the precondition above. We'll change the bounding type of the extrude to through all, and since it's defined right after the parameter, we'll do that in this second code block here, right after the parameters. We'll begin by extruding the slot path, so type extrude and change the entities to definition.slotPath, which is the name that we defined in the precondition above. We'll change the bounding type of the extrude to through all, and since a through all extrude doesn't need a depth, we'll get rid of that parameter, but instead specify that the body type of this extrude needs to be a surface. To update the other tabs with these changes, press Commit, or press Ctrl-S or Command-S. Since our Part Studio has an instance of this feature type, we immediately see it update with the extrusion. Our next operation will thicken this surface. In our Part Studio, type opThicken and insert the autocompletion, and for the entities, we'll query for the geometry created by this extrude using a queryCreatedBy and passing in the extrude's ID. For the thickness, we'll
Yeah, I didn't quite understand. I don't really understand what. All right, so let's just do that extrude and see what's up. So I go to here and I do. Wait, he just typed in extrude. Maybe it's. I mean, it looks like the same. Can I just delete this? Is there not just extrude? Okay, I mean, that's got to be it. So wait, let's just go back. Or wait, let's what the heck? How about now? Okay, cool. Yeah, so we just needed to keep that parameter, and these videos are probably a little out of date.
We'll make this a symmetric thicken by passing in half the slot width to each of the thicken directions.
I don't really understand that. Oh yeah, so what I wanted to know was like, is this thing, you can do an infinitely, I guess you can do an infinitely thin, okay. So we're going to do an opThicken. And this is going to be queryCreatedBy. How did it know? What is, okay, so what does definition refer to? Definition must be all of the things up here. So if I save this, and I go over here, you can see that it did in fact thicken it. Okay. Cool.
Operation take effect. The opThicken created a new thickened part in our Part Studio, but it also left behind the old surface, which you can see in the parts list. To clean this up, we can use featurescript to delete the body. Type and insert a call to opt delete body.
Wait, let's see if we can figure it out. Yeah, okay. So now you just want to do... Oop. Ugh. Oh, controlled. Okay. I don't know these keyboards. So this is going to be queue created by... oh my gosh. Oh my gosh.
Bodies, and for the entities, pass in the same query for the surface body created by our first extrude.
It's not the thicken, it's the extrude one. Now there's two parts. And this is just a normal body. I can sketch on this thing, right? Okay.
Extrude. When you commit this change, you'll see the extruded surface disappear. Finally, we'll subtract our thickened part from the given part to cut with an op boolean. For the tools, we'll use another queue created by, this time for the body created by our thicken operation. For the targets, we'll pass in the definition's part to cut that we defined earlier, and for the operation type, set it to subtraction. When you commit the operation, the part will be subtracted.
Or wait. Wait, definition or... Sick. That's so cool. Let's do a new slot. Slot. Slot path, part to cut with 10. That's so cool.
Subtracted. And that's it. We've now completed a new custom feature type. When you update the parameters to any instances of this feature, the feature type function will be called again and its geometry will be regenerated. You can use your feature as many times as you'd like in as many part studios as you'd like. For more information and how to build your own slot feature, keep
Should I read this? Okay, so what is it that we need to do? I think the easiest thing is one thing is that we don't really know. Oh, it's in the other one. What the angle is supposed to be. Okay. There's no video. There's only 2 tutorials. Yeah. Dude, that's so cool, man. Wait, so let's just try to new feature studio, new feature recon 3D recon. Oh. So this is gonna take a file. So wait, how did we do it again? I totally forgot. We said oh wait, oh, I'm so silly. This is going to be the file, the JSON path file. And it's going to be feature script parameters. Okay, wait, can we just wait, where is our JSON? We need our chords.json. Let me upload it again. Wait, can we just do... Wait, let's watch a video again, because there's also... I think there's a way to just set a...
On the right, the interface displays all of the code required to make all the sketches and features in the gear train.
Dude, why didn't they have someone voice this over?
All of Onshape's standard features are contained inside Onshape in a public document named STD. You can create your own custom features in a feature studio within a document. Custom features are useful in many ways. You can use them to customize a standard feature UI, automate repetitive tasks, create specialized geometry, or automatically set variables or custom properties in parts. It's important to note that custom features can only be used in Part Studios and only affects the Part Studio where it is placed. It cannot do anything outside the Part Studio it is executed in, such as create new Part Studios, drawings or assemblies, read company information, or any other company-wide operations. It is a feature, just like any of the standard features. At the top of a feature studio is a toolbar with options specific to the studio. On the far left are undo and...
Wait, can we just, Wait, we don't want this anymore. So wait, read... Oh, here we go. Blob type. Okay. Let's try that. My data import chords.json. What? Oh, nice. I like that they share it. Choose. Okay, wait, how did he... Yeah, see, that's what I'm saying, is how did he get that? Oh, wait, you know what I think you do? I think I... How do I do this? Okay. Oh, so you can't actually I don't think you can have a parameter that, wait, no, you must be able to. Because, I mean, they did it with this. Like, this is written in featurescript, and it allows you to select this thing. So, we must be able to. But anyways, yeah, that's not the best, but okay. Oh, wait. Oh. Yeah, but that's what I'm saying, though, is like, what the hell? Okay, so, okay, let's just keep going, because I can just bake it in. I don't really care. It's my feature. But so now we want to look at this. Importing external data. Okay. Wait, how do you specify this blob type? Thank God. The value is of a type corresponding to the top level entity file. If it is a map if the entity was an object, an array if the entity was an array. Standard types. Okay, so let's whoa, what is up with my scroll? That's weird. Why is it going so slow? Okay, so let's so this is not going to be this. All right, I want to print out the first. I want to. Okay, so we're going to save this. We're going to go to our part studio. And we're going to do 3D recon. And then where's the featurescript notices? Here we go. Blob type JSON data. There we go. Wow, this has been surprisingly nice. I mean, of course, we had a full Python, so it's not like, you know. So yes, we're going to go back to this. Okay. Okay, so let's just try to get the const A is equal to J zero 0. Nope. Okay, let's save that. And let's go over to Part Studio. And now that okay, and now this is our first point. That's great. So what we want to do is create a point in space with some coordinates. Okay. A series of connected edges which form a continuous path. So first, primitives. Okay, so these are solid body primitives. Wait, what is chords again? Is chords? I think chords is not the paths. Yeah, these are the right wires. That's right. Control Shift F? No. Yeah, there you go. Okay. Chord system. Oh, wait, we have just a... But do we want to represent them all as vectors? I mean, it's the same, but maybe their type system doesn't think so. I'm not sure yet. Oh, cool. They have an... check that two coordinate systems are the same up to tolerance. That's kind of cool. Yeah, so just to compare to Zoo, I mean, look, Zoo is great, but Zoo it does not have documentation like this. They have a couple of examples, but nothing like this. Right, so we got to use all of these, which is quite cool. What I'm wondering is basically what... Because the hope is... Well, whatever. I don't even want to worry about that. I don't even want to worry about the optimization yet. Enums. I don't know about that. Okay, wait. That's it? Path? Okay, what about point? What if I just search up point? Wait, what is a wire? Op fit spline creates a 3D cubic spline through an array of 3D points. That's actually pretty cool. Oh, and look at this. So we do just make it a vector. Okay, so and these are mills, so we're good. So all we need to do in here is const v's is equal to, and then do we have, I don't think JSON, because this is a lot like JavaScript. I don't think JavaScript has a list comprehension, right? List comprehension JavaScript. Do they? Oh, you have a map though? There probably is a map. Let's see. Dot map. I don't know this language. J. Wait, can we print out J again? Wait, no, we know what J is. J is just chords. So if we go to the top, so 0 is this. Wait, do we have do we have this? Featurescript loops. Oh, yeah, okay, this is more... Yeah, this is what I was thinking of. Right, this is just the standard library, and this is the language reference. Types and type tags, top level construct. Okay, wait, let's just read this. It's the way I'm feeling, I just can't deny. But I gotta let it go. Wait, this is syntax and semantics. Wait, where's the loops? Oh, thank God. Wait, but that's... Okay. Okay. So it needs to be... like that, right? Oops. Let's save that, and then just go over to Part Studio 1. Okay, didn't print anything. in a string. Presumably that's not just... Wait, let's just manually go over here. Yeah, how do you get the length of an array? Oh, is it just stored as a... This is their string concat, I'm guessing? Oh, it's size. Okay, cool. All right. Um... All right. So now we just need to make... so now we need to figure out how to make a... Okay, wait, here we go. Okay. All of this seems pretty standard. They don't have ints? That's so funny, they don't have ints. Oh, and they do non-nan, which is great because everyone hates nan. They must have integer. What? Number? So this is a copy? Oh, wait. Okay, so let's follow that second tutorial then. Let's go through the second tutorial. I feel like that makes sense. So what do we do? We do Wait, what? Wait. Did I just misspell it? I must have. Okay. I mean, this is all just UI work. It's not like that complicated. For a length parameter, setting the UI default is more involved since we want to provide nicely rounded defaults for users who've set various default units. The current default is set through length bounds. The second parameter what's the type of it? It's a map, right? But what's the type of meter is the question. Is a meter some sort of higher order function, or what is meter is the question. Let me just type in meter. I don't know. Wait. It's a constant. Okay. Yeah, it's like a public keyword or something. Narrow the slot path filter. While we're here, we can modify the filter for the slot path to be more specific to prevent unwanted input. We know we need to extrude in the sketch normal direction so we can filter out edges that aren't on. We know we need to extrude in the sketch normal direction so we can filter out edges that aren't on sketches. We also know that a slot which isn't a line won't fit together with another planar part, so we can also filter out non-linear edges. I see. Okay, I want to see what's in that. So is an edge. Let's just see what's in here. Line, circle, arc, other curve, plane, point. Notably, point does not seem to be on here. What the hell? Okay. The new geometry needed can't be created using thicket. Instead, we're going to create it using a sketch to give ourselves a fresh start. Let's begin by removing the old implementation. To create this sketch properly, our first task is to create a Cartesian coordinate system defining the position and orientation of the slot. We'll define this coordinate system such that its origin is on one end of the slot, its x-axis is along the slot path, and its z-axis is along the direction we want to extrude. Like the okay. The coordinate system depends on three things: the two endpoints of the slot path and the sketch plane. We will first evaluate the positions and orientations of these entities, then construct the coordinate system based on these positions. Query the line's endpoints. A sketched line will always be its own body in the context. We can find the endpoints on this body with Q adjacent, which can query for vertices of a given type that are topologically adjacent to the slot path. We'll store this query as a variable named endpoints. So it's endpoints is a type query, Q adjacent, slot path, adjacency type vertex, entity type vertex. Okay. Oh, that's so cool. Dude, this language is so sick because they actually made it where it's like, yeah, I'm kind of impressed, honestly. It's pretty nice. They've made it so it's like easy to develop because, I mean, they forced all their engineers to develop in it. So then it's like, you know, they made it at least kind of nice to do. Okay, so we're going to add this. And then we're going to add this. And we're going to save it. And we're going to go to, where's Part Studio 1? Let's delete this. Oh, let's say no. And let's so that's the debug, is that they're red. Okay. Right, will only open when you actually open up the feature. Nice. Okay, evaluate the endpoint positions. To find the positions of these two endpoints, we can use EV vertex point to specify the individual entries of the query, we can use qnth element. So start position is a vector. And it's a little confusing but whatever. EV vertex point of context. I don't know what context is. Vertex qnth element endpoint 0, 1. Now, the question is which gets 0 and which gets 1. Okay, so this is queries like endpoints are objects which specify criteria for finding a particular entity or set of entities in the part studio. These are just specifications and they contain no information about the geometric or topological properties of any entities. Depending on the context it is evaluated in, a query may resolve to 0, 1, or many entities. Now, the other way is geometric entities like end position contain data about geometric positions and orientations, including vectors, planes, coordinate systems, and more. These are just data, and they are not contextually associated with any entities in the part studio. This design gives onshape part studios and features the robust tools needed to maintain fully parametric references. To get geometric information from a query, use an evaluation function found in the evaluate module. qnth element used above is a function which returns a query for one of the entities that another query evaluates to. In general, the ordering of elements inside a query is not predictable, so care should be taken to ensure that qnth element is only used when ordering of entities will work. When any ordering will work, right? That's basically the thing that I've been wondering about. The resulting slot is symmetric, so we are content to define it starting on either end of the line. It should add maybe another thing on I don't know. A vector is just an array of numbers. In this case with units, which behaves naturally under operations like plus and times. Debugging one of the resulting vectors will print its exact location in meters and highlight that point in the part studio. That's so nice. I wonder if there's a map function. Alright, so wait, let's do that. So first we need this. There's no copy button here, bro. We need copy button. This thing is so annoying. Okay. Calculate the axis directions. The axes of our coordinate system will be specified as 3D directions. That is, unitless vectors of length 1. The x-axis can be calculated by normalizing a vector pointing from the start position to the end position. Var x direction is vector equals normalize end position minus start position. So that's really nice. That's super nice. The z-axis can be calculated by evaluating the sketch plane of the slot path and taking its normal. Oh, dot normal. EV owner sketch plane. Evaluate. Oh, yeah. EV stands for evaluate. So Z direction is a vector resulted by evaluate owner sketch plane. Context entity definition dot slot path dot normal. Create a coordinate system and a sketch plane. But is there just an op plane? I don't really understand that. Why can't you copy this? That's crazy, dude. Okay. Yeah, you don't really need to. Okay, so okay, wait. Can we go back to this? What does this actually mean? Bruh. Me as a crow, you're cawing right into my ear. Could you just move over a little bit? That's me as a crow. I mean, there's probably 35 crows here right now. Maybe 40. Might be 40 crows here right now. That's a lot. so interesting because it's like they get real quiet. Nobody's cawing. I guess they're just, I don't know. I don't even really know what they're eating. They kind of move around, but most of them are stationary. They only really come around in late fall. Well, they start coming around in late fall. I don't know when they leave. I think they stick around for a while though. Okay. It's enough bird watching. It doesn't really say, oh, from a point and a normal. That's actually kind of perfect, right? That's like kind of all we need. It takes an origin and a vector. I mean, the origin is, dude, I feel like that's all you need. That's actually pretty sweet. And then you can make a sketch on this plane. I don't know how to do that yet. That's really cool. Where are we? Right, you could have just as easily used a slot path. That makes sense. Okay. Create a coordinate system and a sketch plane. A chord system stores three things: an origin position, a direction for the x-axis, and a perpendicular direction for its z-axis. A sketch plane specifies the same information as a coordinate system so that sketch entities may be placed accurately. Thus, we can also create a plane in our chord system with a single function call. Plane of coordinate system. Yeah, that's pretty nice. And I like that it's overloaded. Sort of. The full code to create a coordinate system is below. Okay. Just copy this in. How do I format? That's nice. Where's my debug? Oh, did they remove my debugs? Okay. All right, here we go. Create a sketch. Sketching in featurescript always involves three parts. Sketching in featurescript always involves three parts. Creating a sketch, adding entities to sketch, and solving the sketch. A snippet can... Dude, I would love to write a sketch solver, like a constraint solver. I feel like that's probably such a good DIY project. A snippet completing these three steps can be found in the sketch snippets menu or simply by typing sketch. What is top? Oh, top. Weird that's not really an... Diagnose a runtime error. In the featurescript notices menu, you can see all errors and warnings displayed. In this case, the issue is a precondition failure. A precondition failure means that parameters to a function have failed to match that function's precondition. To make a sketch in the coordinate system of an arbitrary plane, use new sketch on plane. Nice. Sketch a rectangle. Code containing sketch entities will be placed between the sketch creation and the sketch solve. Do we have the solve? No. I don't like that. It doesn't... I wish it would just format on paste. The first entities we need in the sketch will be a rectangle which will be as long as the slot path. Let's first define a variable which represents the slot length, calculated as the distance between start position and end position, which is norm. On the line, after defining the variable, we can insert code calling skRectangle by using autocomplete or by using the sketch snippets menu. That's kind of cool. Okay. Every sketch operation has a sketch ID. Unlike feature operation IDs, a sketch ID is just a plain string. A sketch ID needs to be unique within a sketch. The vectors positioning the corners of the rectangle are 2D length vectors measured in the coordinate system of the sketch we provided. With the origin at one end of the slot. Wait, how do you know? How do you know, though? Isn't this order dependent? Yeah, see, that's what I'm saying, though, is like, if the start position wasn't the one at the end, like, wouldn't this be... So, I feel like this does depend on which one you get from here. And they're just assuming that you actually get the one at the end first start position, but they said don't rely on it, so it's kind of weird. If it works, it works. The vectors pointing... Okay, this means that we can easily calculate the precise coordinates needed for the rectangle using the slot. Yeah, so from there to there. Whoa, and now they all leave. That's the crazy thing, is just all at once. Wait, but they might do a loop. They might come back around. That's the funny thing. Oh, and a couple stay as their beacon. Oh yeah, they're back. Wait, how do we specify a point? Entity type dot vertex. Yeah. Okay. Wait, did we add all this? That would be insane if they didn't have an iterable loop thing. SKArc. Okay, I feel like we could figure this out now. So, what do we want? We want... Or let's do... Okay, so 2 vertices. Let's do the thing... Well, actually... Wait. Can we just provide input? How do we just provide... Wait, let's go to that... Probably this. And then when they did this, they got to reference vertex. I don't really get this. Can we just play around with this? Okay, but can we see the code?
Here's a quick tour of the freeform spline feature that I wrote for onshape. It's essentially a fit spline through points that you can drag around in space. So I will click add vertex here, and it will create a point at the origin, and you'll see this triad pop up. I can use the triad to move the position of that point, but the feature is failing because we need at least 2 points to create a spline. So I'll click add vertex. Every time you add a vertex, it puts it at the same exact position of the one before it. So now I have 2 vertices on top of each other, and I can drag it out. Once you begin dragging, the spline...
But it's still an absolute coordinate, thank God.
And drag, and add, and drag. And if I want to edit any of these points, I can just go back and select them and move their position in 3D space. So this is a good way to route wires and things like that. And because the idea is to route wires, I can also select a reference. So I have added a vertex, and it puts it at the end of my spline. And I can go here, reference vertex, and grab this point in space. And it will place my point there, and it will also set my x, y, and z values to 0, which means that I can offset from the reference if you want to. So I could either type a value
Yeah, so let's look at the code. Because basically we just want to make a custom feature that, let's see, where is it? Where the hell did it go? Template. Okay, so I'm going to copy this in, actually. Wait, hold on. Do we need this? I don't know if we need... We might need all of this. So let's do this. Like that. Except we're just going to... Oh. Yeah, this editor is not amazing. Okay, let's go to Part Studio 2. Let's do 3D Recon. Add vertex. Nice. So we should be able to refer to okay, so now we have that. Now how do we refer to them? We have vertices. Okay, so what we want to do is we need to, can we, is there assertions? Can we say min? Can we specify the min? Okay, so to do, whatever. We're going to figure that out later. Because, I mean, we're going to be parsing this anyways. So let's just say that we have var a is equal to, so we can close this, is equal to definition dot vertices vertices 0. Copy paste. Oh Jesus, I don't like that Control C doesn't. Control C should just copy the current line like it does in everything else. Okay, then this is B, and this is 1. So now what we want to do is we actually want to create a plane. So plane, op plane. And it takes the, wait, where does it say what is what? I thought it said something useful. This docstring stinks. I'm pretty sure it says, yeah. Plane origin. So we're going to give it 3 things. Oh, wait. I guess we're only giving it 2 things. Yeah, it's this one. Origin is vector. So this is going to be A. And then this is going to be normalize B minus A. Can we see if that worked? That'd be sick. So we have 1, 2, 3. Okay, so what failed? Okay, these are warnings though. Cannot multiply map value with units. Okay. Oop. I wish it would just open it up in here. So 57. A is probably already in. Wait, it's a map? But I gotta live. I wonder if it actually adds the feature, though. That's the interesting thing. So this fails because cannot subtract map and map, which actually checks out. But the thing is, I want to... Okay, let's just do the obvious thing. I mean, this is really not that hard. You basically just say... Okay, we want to define a function. How do I define a function? Oops. Export func. Okay. This is array point index. We don't need that. We just want to do two vertex. And this is going to take a x of type map. Can I do map? Is there a reflection in here? It's kind of annoying that it... Let's see. Does this hover show me anything? It's the way I'm feeling. I just can't deny when I gotta let it go. Functions, bro. How do I make a function? Returns. Well, that's cool. Yeah, but how do you specify? Oh wait, do you? Oh, does it? Is it like an is? They say. Yeah. Oops. X is map. Yeah, there you go. Okay. Return. So this is going to be a vec. How do I make an array? I think I can just do this. Oh my god. Dude, this is so annoying. Notifications. Dude, stop. Just stop. It's never... Dude, Microsoft is so stupid. Okay. So we want to say to vertex. Oh wait, don't we want to say vector? Is vector a function? Make a vector from an array. Okay. All right, let's try to save it and run it. Oh, damn, bro. I'm sick. I'm literally sick. So it makes a plain... So wait, I can't tell. If this is right... Wait, this is top. Okay, so X is positive there. Oh yeah, so... But, okay. And it is slightly angled, which is good. But now we want to actually draw the line, right? So we actually want... So this is okay. So this is the plane that the sweep profile lives on, but that's not. And I feel like I just want to do it the dumb way. What I'm wondering though is how do you do the what is it, vertex normal plane constraint? Because it doesn't seem like any of the op plane constructors really have that. What is the next step here? The next step is to I forgot. I already forgot. So plane, yeah, we want A to be the origin for sure, and then the normal. So I don't get what this is. The x-axis. The x-axis of this plane's coordinate system will be an arbitrary vector perpendicular to the normal. So the normal is this way. So x could be any of these. No, I think we need to specify x. So we need to then know if we're like this, it could be any of these. So we need to know, so we want to provide x for sure. All right, so what do we need to do now is we need to make the sketch profile, and then we need to draw the line, which means, okay, so I want to do that first. I'd rather do that. So we need to make a plane can you just take the normal of this? Array index. Okay. So how do you define a plane? Wait, can't we do it the coordinate system method? Where is that thing that we were reading? So we want to take this vector, it's pointing like that, as, what is that? If that's the x, then we're actually looking over here. But I don't know if I want to normalize that. I don't know how, or like coordinate system, presumably you can scale it. I'm not exactly sure. So if we're looking this way, and, or wait, okay, let's just say we're like this, and we're looking this way, Y is that way, Z is that way. Did they normalize that? They do normalize that. I feel like there's got to be a simpler way, but how did we do it in the other guy? If we go here, so you make one plane that intersects that, one plane that intersects that, then you make a plane. How did this guy get made? What? Right. This is the normal. How is the normal made? The normal is made with the vertex edge, point normal. Can we see the code? It's probably in the standard library, right? Wait, these are all the... Oh, here we go. But then we have to set up the queries. I kind of don't even want to do that. It would be nice if you could just provide the... Oops. You would just provide the X instead of the norm, instead of the normal. Okay. I'm pretty sure that it's just a simple permutation of these, right? Let's ask ChatGPT. I have this code for onshape's featurescript language, and this creates a plane. So the plane function in this snippet makes a plane where A is the origin and the second argument of plane is the normal. And so, but what I actually want is that is the other way around, is that the second or basically I want a plane where both A and B lie on the plane. Is cross even a function? What is the cross product? Wait. Wait, can't we just do this? Can't we just do this? Let's comment this out. Copy this. And it's going to be, instead of that, that's the X. So if we're like this, the normal, so this is going to be the X direction, right? So now we're living like this. I don't think this works. Let's just put B in here. I feel like this is going to fail, right? See, this is the normal, though. Wait, but that doesn't even make sense. Oh, I keep losing my tabs, man. So what? Let me get a pen. What am I even trying to say? You have A is equal to 1, 2, 1, 2, 3. You have B is equal to -3, 6, and 4. And let's just say the AB line is equal to -4, 4, 1. We did this yesterday, or 2 days ago. And so this is going to be the x, right? So this is the x part. So what we want, wait, can we just do it in 2 dimensions for right now? So we have 1, 2, minus 3, 5, 6, 6. Okay, and so what we want is, so this is going to be minus 4, 4 is equal to AB in 2D. And what we want is the normal of that. So if we just flip them around, right? Isn't that right? What is 4 minus 4 as opposed to wait, okay. All right, forget all this code. Let's just say that we have 2 points. Point A, wait, it's not working. Dude, sometimes I swear this website, it just like fails. Come on. All right, forget all of the programming. Let's just say we have point A at 1, 2, and B at minus 3, 4. And so that makes the vector from A to B equal to minus 4, 4. Now what I'm wondering is, how do you compute the normal to that vector? Dude, this just goes to show how bad I am at math. Wait, these aren't even the same. Oh, wait, okay. So minus 4, minus 4. Yeah. Okay. Yeah, what about a 3D normal? To compute a specific normal vector in 3D, you need another reference vector, W, that is not collinear with V. Okay, the cross product is what we're talking about here. Okay, so the cross product of 2 vectors gives me the other one. So we have, okay, and we need to do it with reference to the origin, I feel like, because when we go and look from our point of view from A, We need to know how much to rotate so that we can pick X. We need it, well, all right, we're making two planes. One, okay, so we'll call, there's profile plane and path plane. Right? So we have yeah. So wait, why don't we just ignore that and just assume that it's a flat path? So meaning the z of a, or az is equal to bz, which in that case, because that is actually true for the G code that I have. Well, at least the simple test case that I have. So great. So now we have, okay, so then we have to change our A and B points, but that's okay. Yeah, so let's make A equal to 1, 2, 0. B is equal to -3, 6, 0. So now, just looking from up top, we have, yeah, we have the same graph as we have before. So our X, so the X is going to be, okay, yeah, clockwise. Okay, so it's y minus x. So it's 4 minus 4. Okay, so in our case, so this is x. This is x for the profile plane. And then z, which is the normal, is going to be b minus a. Do they have a way to rotate vectors like that? So wait, first off, let's go to wait, how come I can't hide that? Why can't I hide it? We want the so in the profile plane, the normal of b minus a is the x for the profile plane. But x for path is b minus a. Okay. So this x for this one the hell is it? I think it is 0, 0, 1. Does still fail? I think that this is just going to be A. Oh. Wait, oh, okay, whatever. I don't give a shit. That doesn't look right, though. Okay, so let's simplify. Let's say I have 2 points, A and B, and their Z component is the same, so they're not at different heights. I need 2 planes. I need a profile plane that uh, that is perpendicular to that has an origin at A and is perpendicular to the vector A to B. The other plane that I need is intersects both A and B. I guess, and I think is perpendicular to the profile plane. I don't know what that even means. So the software I'm using it has a plane function. It takes 3 arguments. The first is the position vector of the origin. The second is a vector normal. Let's see if that works. That'd be sweet if that works. We don't need that. We just need this. Okay, that looks right. So now let's make the sketch. I think I'm gonna make some food. I think I'm gonna make some kimchi fried rice. Kimchi fried rice. Okay, so now we want to sketch on plane.
And redo buttons. They work just like a part studio, assembly, or drawing, meaning they are only active for the current session and independent of other users that may be in the studio. The new feature button inserts the template for a new feature. To the right of it are pull-down lists for parameters, queries, evaluations, math functions, sketch functions, and operations. Each list contains commonly used functions, but is not comprehensive. We will learn more about using each of these types in later videos. Further to the right are the import and format buttons. We will learn more about importing in a future video. The format button formats the code with the proper indentations, so it is helpful to use prior to committing the code. The blue commit button commits the code and makes it active for use. All changes are always saved in the versions and history graph, similarly to any other tab, but you do not see any changes in the part studios where your custom feature is used until you commit it. The featurescript editor is based on the ACE editor. Many of the same keyboard shortcuts work, such as toggling comments with Control or Command/ and committing feature studios with Control or Command S. To get more information on a function, mouse over it and the documentation pops up with tips. To see its full definition, hold down Control or Command and select it. The function definition opens in a new tab. This works for standard as well as custom functions you may have defined in another studio. When you add code to the Feature Studio, it recommends functions based on the standard library. You can use the up and down arrows on your keyboard to cycle through suggestions and press enter to autocomplete the function call. It puts in default values for the parameters that will likely need to be changed. Use tab to cycle through these parameters. Press Control or Command F to bring up a search. You can search for any keyword in the active studio. Select the plus sign or use Control H to replace keywords with others. You can find and replace one at a time or all at once. Use the magnifying glass in the top right to search all feature studios in the document. On the top left, type in the keyword you wish to search by. You can apply filters for case sensitivity and regular expressions. On the right, you can filter by feature studio name. Click on an individual line to bring up the instance where the result is found. There are many resources to assist you in learning featurescript. Open the help menu and select featurescript documentation. You can also access it directly through the link. The landing page contains a welcome and a quick walkthrough video to get you started. Tutorials contain more in-depth examples. The standard library documentation contains a listing and explanation of every call available. Specifically, in this course, we will focus heavily on the topics under modeling. The standard library source opens the public document that controls all of the standard features in Onshape. The featurescript guide explains in more detail how to define a custom feature correctly. The language reference section describes the conventions as well as what functions, expressions, and statements are valid within the language. Additionally, the custom features page contains many high-quality completed scripts that you can view, use, copy, and modify. It is easy to get started building a custom feature. In a new document, select the plus to insert a new element. Select Create Feature Studio. An empty Feature Studio will always start with an import for the standard library and declare the version of feature script being used. Name the Feature Studio cube. Select New Feature at the top to insert the basic framework for a new feature. A feature is made up of a function declaration, and within it are the precondition and body. Comments are automatically inserted to direct you to the appropriate areas for customization. You can delete them or leave them. The annotation contains the name of the feature. Name it cube. The constant contains the custom feature's internal name as well as defined areas for the inputs and actions. In the constant, change my feature to cube as well. The precondition is where all user inputs are defined. Select inside and select the length parameter from the feature parameters pull down. We will go into more detail on other parameters in a later video. Change my length to side length. Change the definition identifier to side length as well. Move the cursor into the body where you define the feature's actions. Select F cuboid under the operation functions menu. This function takes in two inputs for the opposite corners of the cuboid shape. Multiply the vector for corner 2 by definition.side length. Remove the inch units from corner 2 because side length already includes units. Select the commit button to commit the changes to the custom feature. Go to the part studio and notice that the cube entry is available. It is in the custom features in this workspace menu. It puts a cube at the origin with the side length you specify. This basic script identifies the key components required to create a custom feature. The user interface is how the end user views and interacts with the custom feature. As the author of the custom feature, you decide how the feature appears in the toolbar, what icon displays, if there are any tooltips, and all of the user inputs in the feature dialog. We are going to start the script for a dome feature that we will continue over the next few videos. The dome feature takes a circular face and applies a convex or concave dome to it. In this video, we will focus on getting the name, icon, and tooltip to display correctly. In a new document, create a new feature studio. Define a new feature. It automatically adds an annotation to define the name of the feature and a constant that contains the rest of the feature information. The feature annotation is what communicates to the rest of Onshape how this feature should appear. The feature type name is required for the script to be recognized as a custom feature. It is important to update the default values to text that matches the custom feature you are building. Edit the feature type name and change it to dome. There are several other optional annotations you can add. The filter selector declares what keywords would cause your feature to be retained in the feature list filter. The feature...
Okay. What's up, bro? Yeah, honestly, right now, I feel like today's been pretty slow, but I'm starting to get it. So basically, now we have two planes, and we made it with this code. So our current feature script I don't know if you can hear me. Our current feature script. First off, I figured out how we can do JSON, so that's good. Because the coordinates that are going to be exported from the slicer, the G-code is JSON. Then this is just the parameters, so that like when you do this, and you make a 3D recon, you can pick whatever vertices you want. Actually, let's do this again, and let's see what happens if we pick this and so wait, we actually want to switch this up because we in the feature studio we just want to make this normal AB. Let's see if we can get this. Wait, normal AB? The extra second, wait, second plane is this is the path plane. The path plane, shouldn't the X in the path plane be the vector AB? All right, let me put this food away really quick. Yeah, this needs to be, wait, what is this? I feel like this needs to be vector AB. And this needs to be fucking editors. God, I hate editing text. No way this works. Wait. The fuck? If you point up there, then what? Bro, why am I so stupid? Let's just go back. I mean, this does it. It's just that they're not. perpendicular. But anyways, now your geometry. Okay, wait. So let's just draw. Okay, so now let's just make a sketch. So where was that thing? So first we need to make a sketch plane. Isn't it just we have a plane. Wait, am I dumb as hell? Bro, these guys really coming back, man? Come on. These crows, bro. These freaking crows. Wait, can't we just do this? This is going to be normal AB. This is just going to be extra profile. Now that looks pretty correct. Dude, why was I tripping out about that so much? Oh, but this actually... But do I want to do normalization at all? What does normalization do? It's a sketch on this plane. Yeah, but the crazy thing here is Wait, what is the sketch plane? Oh, yeah. Okay. Bro, why is this so confusing? Is this even right, dude? This doesn't sound right. Wait, where's the other plane, though? Damn it. Okay. So, on this plane, the sketch is on that plane, right? This isn't even right. Because if Z... Wait. Wait. Oh, this is a... I can't tell anything. So much code. All I want to do is make a line. Why is this so confusing? Okay, let's just say I'm looking at B. I'm at A and I'm looking at B. I want my normal to be 0, 0, 1, which is true, yeah. Then I want my X. Oh wait, let's do this math with like unit vectors so that I'm not being a total idiot. That is my pencil. Okay, so let's say A is at the origin, and I'm looking at 0, 1, 0. So I'm at 0, 0, 0. I'm looking at 1, 0, 0. And I'm just gonna say, okay, so what's the cross of that? Can we just open up a normal thing? Wait, what is the cross? Ah. Yeah, okay, wait, so the plane that I want is that X is equal to 1, 0, 0. My So let's just manually make some planes. I say we do a... Let's just do a new parts... Let's do a new features... Part studio and a new features studio. Okay. Let's copy the... Oh yeah, we have to do new feature. Okay, so So wait, we need this. So this is going to be 0, 0, 0. The normal is going to be 0, 0, 1. So what? I don't really get what that means. What does the normal actually mean? And then here we're going to get a vector. Oh, wait. So wait, if we change this to be now we're facing to y. Okay. So the is the cross of A to B? Bro, what the fuck? If I have two vectors maybe like this, they're not collinear, but they're not perpendicular. That's why the I'm having a hard time understanding some math, I guess related to 3D geometry. So let's say I have two random points, A and B, in 3D space.
Got it.
Wait, hold on. The first, the first,
Sure, take.
bruh.
What's on you?
Dude, this thing is so fucking annoying.
I'm here to help. Let's sort it out together. What can I assist?
Okay, so you have points A and B in space, and I want,
Got it.
I want a plane that,
You want to find a plane related to these points. Are you looking to define a plane that goes through both points? Or are you thinking of something else?
yeah, it goes through both points, but the function that you call, you don't provide the points. Wait, what if I just try to make a C-plane? Why don't I just try C-plane? Or do you, to do C-plane, do you need, is that it, man? How do you make a seaplane? Do I have to import something? Okay, let's just do that. So, okay, so the plane, let's see. Can I sweep a profile that's not on a sketch plane? Okay, for this doesn't matter. But, so you do need to put the, right, it just sweeps it along those vectors. That's kind of weird. Okay, I think I want to do this. I'm just going to do a new thing. This is bothering me. Okay, so what do I want to do? I want to oh, wait. Let's do this. It's gonna be the top plane sketch line goes to here. Great. Now we're gonna take. Okay, how do we query a sketch entity? Let's just ask it. How well? Wait, hold on. I want to do this. How well do you know featurescript? Show me how to create a sketch on the top face and make a line from like the origin to like 20 comma 20. Then I want you to show me how to query a sketch for all edge entities. Okay. We need to now Bro, why is this so hard? Okay. So, wait, how do we do that with featurescript? That's what I'm trying to figure out, though. So if we do this plane, because we only need it for the first in a wire. Line point. But how do you get C-plane? Yeah, how come I can't use this? And where is it? Q union this thing. Can we also, I also want to try, let's comment this out. Oh, it's such a beautiful shape, dude. The saddle. That's so cool. That's so annoying. Okay. Oh, hell yeah. That's what I want, bro. So we make a big polyline. So why can't I use C-plane? Because C-plane would be really nice here. Wait, we know how to do this one though, right? The X is gonna be the X is gonna be what? Or we could just say the normal. Okay, let's make a Oh, that's sick. Returns a transform. This takes 3D points measured with respect to a plane. Or rather, this makes more sense. Okay, so let's just do this. Op plane. So let's just make this. Wait, what does op plane do? Oh wait, what was I doing before? I think I was just calling the plane function. Oh, right. Okay, wait. We just want to make plane. Wait, why am I tweaking out so much? What was I doing back here? Oh yeah, and then I had to do this. Op plane. Right, okay. Cool. Where is it? Why can't I see this thing? Wait, what the hell? Okay. I need help with taking an arbitrary polyline, and basically what I need to do is I need to make a sketch that is normal to the first line in the polyline. And it needs, and then on that sketch I need to make a rectangle that's 4 millimeters in length and 2 millimeters in width, I don't know, in the other direction of the sketch plane. And then I want to sweep it along the polyline. The problem is it's not going to be right. Wait, this should be right. That's what I'm saying, bro. What the hell? Why doesn't it show the plane? Value sketch plane is query. Was it this one? Was it this one? New sketch on plane, that's what I want to call. Did it make the sketch? But then where's the sketch? But where is the sketch, bro? What if we just... New feature. Oh yeah, you have to do solve. I forgot about that. Why is it all the way over there? I have no idea. It doesn't even make sense. It should be lying on... I mean, that doesn't even make sense. I don't even think you need this. Do you need this? Okay, well, I guess you do. So can I do this? Did I forget one? Oh yeah. Okay, and then we're gonna make a rectangle. Wait, so where did our rectangle go? Oh yeah. Wait, can we see the sketch? Do you get to modify it? What the hell? Okay, wait, so now we want to extrude this. I'm literally insane. Well, let's just try this. Okay, that's cool. Anyway, dude, it's hot out, bro. It's dang hot out. Dude, what the hell? What does that mean? Lock profile direct. Oh, interesting. Now that's cool, actually. How do you get a direction? I don't really get it. Oh wait, I messed this up. This is so cool, dude. Okay, so let's delete the sweep. Let's delete the sketch. And then let's figure out what was going wrong with my sketch. So first, damn it. It's not Monaco, bro. It's not Monaco. Millimeter. Let's fix that. There we go. Okay, now we just need to do an op sweep. This should be easy. Okay. How do you just get... Can I just do this, or is this not going to work? Wait, what does it return? I'm actually curious. It might return nothing? Oh. Profile, keep orient. No, we can just comment this out. Oh. So then what fails? How do you... Okay, wait, let's... Focus, bro. Okay, wait, are we at the sketch part yet? When do we make the sketch? This doesn't make sense to me, but that's okay. So we were able to make the rectangle. Okay, wait, but when did they do the extrude? queue contains point. What does that even mean? Oh, they have a pipe? That's kind of nice. That's kind of cool, actually. Yeah, where did they explain the difference between a query and data? Did they ever explain like what ID means? Uh Oh wait, we should have saved that thing. Let's Let's pause the let's pause the sweep, and then we're good. Okay, and I want to print this thing out, actually. I feel like that'd be kind of fun. But see, the thing is... Oh, wait, no. Or not extrude. Oh, wait, this one's different. That's okay. Let's just save this and print it. I just kind of want these things. And maybe we can see if my printer actually sucks. Nice. Let's see if I can do it. Oh, shit. Wait, what the hell? Wait, something is very weird. Wait, what's going on? What the heck is going on, man? First off, this is crazy cool. Wow, that's cool. But, was that like that? Let's do a new. Oh yeah, what the heck is wrong with my Bamboo Studio? I feel like it lost on my profiles. Yeah, where is my... Why is it all A1s? Device? Oh, I think I just accidentally did this. Yeah, this is correct. Okay. That was weird. This thing is so cool. All right. Dude, I bet this thing is, no, I don't know. Oh, wait, there, you can see it. See how it hasn't fallen yet? That's what I'm talking about. Like, what is going on? Yeah, look at that. Dude, I'm so glad I got that on camera. Wait, but did it fall? Did it fall into the build plate? I honestly can't tell. Wait, we'll find out in a minute. No, okay, and now I feel like pretty confident that this, wait, there it is. There it is. Why is it doing that? Oh, wait, did it fall? It fell off. Well, anyways, I mean, I feel like it still demonstrates what's going on. It's like, I know what it is, bro. I'm just being dumb. There's residue on the hot end that just doesn't come off, or rather, I think it seeps from above. Okay, well, I feel like this print's gonna succeed, so that's good. Okay, so we just need to do this sweep. How hard is that? We're literally almost ready. It's like all you have to do is you take the JSON, then you like do them. Dude. Yeah, you tree map the leaf nodes to turn, or the leaf arrays, I guess. But whatever. You go for coordinate pair in J, map vector onto each coordinate pair, and then you store those, and then yeah, it's so easy. And then once you have or actually, wait, no, we want to do this with the wires. Yeah, so there's one more level of nesting. And anyways, you just create a polyline. Dude, it's weird that, like, I didn't even know about polyline, but a lot of this stuff just works with normal, like, vectors. Like, it feels like you're way more constrained to it feels like you're way more constrained to 2D geometry when sketching in the actual GUI than this. Okay, so we just need to sweep this. Why isn't sweep working? I feel like it's because you have to do some weird Q thing here. Q sketch. How? I feel like I should just be able to use rec. Like, why am I coding in a way that makes no sense? But it doesn't work, right? It fails. Wait, first off, okay, let's delete this thing now that we're... Wait. Okay, what is going wrong here? Sweep select profile. Okay, so you definitely can't do this. So what is the way then in here? You gotta go all the way down until after you op extrude, region to extrude. Okay, so we just need Q contains point, sketch region, sys.origin. I don't even know what that means. They don't really explain that. What does contains point mean? I mean, what is... Okay. So let's go to... Is there a full code at the bottom that I can copy? Hell yeah. Oh, hell yeah. Okay. A query for all. Okay, wait. How about I just ask ChatGPT? It might not know specifically, but Q sketch region sweep sketch. Can I do that? Let's try that. That doesn't really make sense because select sweep profile. Dude, I want more tutorials. Wait, can we watch a video maybe?
Feature name template allows you to change the default naming convention used for new features in the feature list. UI, start and end. If opposite direction is true, set it to a negative value. Otherwise, leave it as a positive value. In the subtraction boolean, set the tool profile. Now, when the dome is inverted and the error is triggered, a warning appears. This custom feature, calculate their values with respect to the edge length. Create a constant named sketch1 and set it equal to the result of a new sketch on plane function. Aim for the sketch plane function to create a circle. Enter notch radius in a part studio. The sketch is positioned perpendicular to the edge at its midpoint. To create a cut, you need to combine an op extrude with an op boolean subtraction. Op extrude contains many required and optional parameters. For this example, the cut should stay centered on the edge. This requires the entities, direction, end bound, end depth, start bound, and start depth parameters. The entities parameter requires a query for its input. Use the QSketch region query to reference the sketch face.
QSketch region
Enter
sketch ID. Okay. Op sweep. QSketch region sketch ID. Isn't that what I do though? So wait, did it complain about? No, it's still complaining about the profile. I wish they had an examples thing like most other people. Like, sometimes you can just like I like when you can like see a whole bunch of examples. Wait, let's see feature script examples. Nice. See, I knew someone would. Oh, but this isn't what I want, dude. I want to be able to search the code for sweep. Wait, actually, wait. Hold on. Let's do those custom features thing. Wait, what am I looking for? Custom feature. Dude, let's just take this and close to the right. It's gonna be so much code though, and it's like I feel weird because it's in a different environment. Okay, wait. I just want the spline one. I just want to see because he probably has an op sweep in the. He doesn't sweep. Wait, actually, can't I just go to what I had? I should have freaking saved it, bro. Let's just get rid of the op sweep, and then we add back in the. I can't believe I keep doing this, but wait, we need the rectangle. Do we have? Oh, we do. Okay. So now we want the sweep. This along this polyline. And what do we want to do? Now we want to see the code for this. So now we want to see the op sweep. But there's no op sweep? Feature sweep. Oh, they just call it sweep. What's the difference? I don't get the difference between these ops, bro. What the hell are the ops about? On God, bro. Okay, so let's just call sweep. Yeah, because like up here, I just called plane. I didn't call, and that's how it should be, man. I hate all this, dude. That's why a wait, there's no just sweep function. God, dude, it's like the seaplane thing. It's like the seaplane thing. That's crazy. So wait, you go to the Part Studio and you see a sweep function. So I want some. Wait, let's just see if this. Let's just see if this wire routing one does it. Oh, nice. That's cool. Oh, that's so cool. I want to. Oh, they don't have a previewer. Wait, where is the actual feature script thing? They don't have the source code for this? That doesn't make any sense. I don't see the, this is just the, oh wait. No, I don't see any, oh, here you go. All tabs. Wait, what? Oh, here it is. Can I just, but I can't, dude, that's, okay. That's the problem with having your own editor like this. It's just like, there's some advantages, but this is just like, open this up. Like, is there a sweep in here? No. Is there a sweep in here? Okay, is there an op sweep? I just need an example. Okay, let's just see. Op sweep feature script. I feel like what you get is you get. Please, dude, I need an example of. Oh, nice. Wait, does he have the freeform spline? How do you even get that? No, that's the custom thing though, right? Wait, Alt-C? Oh, you can't edit this. I need an op sweep. This is gonna freak me out. Is that what's failing? That doesn't make any sense. 2022. This is probably my best bet. New sketch, rectangle, sketch, circle. Sweep. Yeah, this is where the, okay. Wait. Is this old? I feel like this is old. Profiles. Queue created by profile 1. You face. Oh, this is just how you select literally all of them. Dude, this is so general, but okay, I think I get it. So I think what this is saying, I wish I could get validated on this, is that, wait, what does Q created by do? Can we copy his code? This is wrong, right? I'm trying to use a sketch as a okay, yeah. Sketch entity query. Wait, okay. For the profile, I could use this. Let's try that. So wait, can we save this as like a real thing? Comment this out, and can we just version? Save this, create a version. Honestly, well, I've never done it before, so it's cool. Made a version. All right, but we want to disable this. Honestly, I'm fine going back and forth. But so instead of this, we wanted to do this. I crash it. Oh wait. Ah, but it's still goofed up. Wait, let's delete this. What's wrong with this? Sweep select profile. This is such a bad error message, dude. Sweep select profile. Can I go to that? Okay, profiles needs to be a query. I don't know. Path also needs to be a query, so that L is wrong, because let's just do some type checking ourselves. Get our sleeves. What does this return? This returns a sketch. Yeah, it's actually annoying that these aren't, like, what is this? Why doesn't it give me a doc? Okay, there. Gets the wire body entities. Wait. First off, can we, oh, please this work. This would be awesome. Yeah, okay. Wait, can we just read that whole thing? Try to actually understand this. I'm trying to use a sketch inside featurescript as a path. Yeah, and I'm trying to use a polyline. It works fine when the sketch contains a few connected lines, but there's an error when it comes to closed loop. I kind of doubt that. Okay, can we just read through the Why is it always closed? Oh, yeah, dude. I gotta think like I'm actually gonna design one. Now you create a plane normal to the. You create a plane normal to where you're going. Okay, you like that. Now you're going to plane explain queries in featurescript by onshape. No way this is freaking right. Q edge. I don't think that's a thing, man. I mean, it's sort of like estimated it. How to query for sketch rectangle feature script. There's just not enough information. Wait, can I do this? Queue created by, and then what is this? A query for all the entities created by a feature or operation. Wait, so you know what I want to do? I just want to make some queries and debug it. Like, I'm just acting a fool, man. A query for all of the entities created by a feature or operation. The feature is given by its ID, which was passed. Dude, I wonder if there's some sort of like lexicographic ordering for these boundary representation things. Like, how do you name them? Because I feel like there's no way to name them. That's the crazy part. I don't know. And that's why this is so weird. Like, how do you name the geometry? The feature is given by its feature ID, which is passed. Okay, an entity is created by an operation if the entity was added to the context as part of that operation. So presumably the context. Can I just print line context? Let's just see what the heck. Print line context. It's given to literally everything, and I have no idea what it is. Because I mean, this is exactly what it was when I was building CAS. It's just like you have to have a context that manages everything, stores the state of the system. So let's see. Oh, that's actually so annoying. What the hell? I mean, that doc string just makes everything more mystifying. That's the annoying thing. So where were we though? So they should just make a desktop app. It's not that crazy. Okay, whatever. I saw the thing that someone used Rust Tari or something to like automatically generate a desktop app. Oh no, maybe it was Electron. I think it was Electron, but yeah. Okay. I was reading a good doc string. Was Q created by. So wait, can we just? Okay, so wait, actually, yeah. Let me just stop being dumb. So what we want to do is we just want to say var fs is equal to this, and then I just want to print. Oh yeah, dude, this. Okay, whatever. I mean, it's honestly fine. I want to just dump that. Oh, come on. What does it say? Okay, so it's literally just. What? Wait, did I still say extrude one? Can we make this sketch one? And now how do I actually evaluate this query? Evaluate query. That's what I want, right? I mean, oh, dude, this is driving me crazy. Oh my god, I can't get over it. Wait, let's see if they have a featurescript VS Code thing. The problem is that's the problem with having your own, like, system. I mean, that's the same problem with Zoo, man. They're trying to make a business off of, like APIs and nonsense, but it's like, I don't know. It's just like, I just want the best CAD. I just want to express what I'm trying to say, bro. Dude, the AI CAD is like, AI CAD is like so, but like, Like, what you need to do is you need to, like, use that alpha geometry, like, okay, what example of one of the problems that it solves? It solves a proof, but it's like, all these nerds say proofs are the same as programs. Like, a program is just a proof of something that, like, doesn't crash. I don't really know how they put it, but it's like, presumably, like, yeah. What's example one of the problems though? It's they wrote it in Python, but like didn't no, here's a simple problem. Perfect. Let ABC be any triangle oh, those two angles are that's actually so cool. Okay, I guess what I'm trying to say is like the problem that I'm trying to solve. You have a line in space from point A to point B. That is the same as one of these statements. A, B. I wonder if you can try this thing. The problem is like, sweep is kind of a higher level function. Okay, what were we actually doing? Evaluate query is what it sounded like. Okay. Oh my god. Wait, I just want to see, dude. That's the thing about this tutorial I'm actually not happy with. It's like one of these things, bro. What are you doing? Wait, can I just debug? Wait, is that what it is? Can I just debug this? How do I select this? That's all I want to do, bro, is select. Select sketch element feature script. I feel like I'm asking the wrong questions. I'm trying to say sweep all these faces. And then please give me another error, bro. Please. Oh, wait. Wait, where was that query results to nothing? Oh. Damn, dude. What is going on? Please tell me. Oh, maybe it's this. What if the path is. Okay, I'm just going to write a thing because I don't understand this at all. Yeah, I just need a CAD kernel, bro. I don't need all the other stuff. Okay, so what is it that I do? I do. We can make this A, B. Okay, and then so we take two vectors, then we make a polyline, then we make a plane that goes from A to B, and we make a little rectangle. What about rect? What if I did rectangle 1? Where? Oh yeah. Wait, 57? Oh. The error message is so annoyingly bad. Okay, I'm just gonna post. I feel like that's reasonable now. I may be kind of dumb, but how do I post? New discussion. How can I sweep in feature? Okay, wait. I'll just put feature script. I don't know. How can I... Oh wait, is this only about feature script? How to sweep a polyline. Hello. I plan to sweep a profile across all of the paths that my printer is extruding. This is to recreate the printed geometry for stress analysis. I am having trouble understanding how to call op sweep. So I'll say, I guess I'll share. Wait, let's make a here. Well, I'll just put the code. That's so much easier. Where's my thing though? This is my code so far. Wait, what? Can I do this? Oh, code block. Okay. I am able to get far enough to where... Wait, does it fail? Wait, actually, you know what? Wait, can we just read the docstring one more time for this thing? Profiles is a query. So can we see op sweep? profiles, but it just says profiles is query. What is query? A query identifies a specific subset of context's entities. Yeah, okay. The fields on a query map depend on its query type and may include one or more subqueries. A context is a built-in that stores modeling data, including bodies, solids, sheets, wires, and points. Their constituent topological entities, faces, edges, and vertices, variables, feature error states, etc. Every Onshape Part Studio uses a single context. All features, operations, evaluation functions require a context to operate on. Dude, okay, now that I'm really reading this, I mean, it seems more clear how you even make your own CAD. Each context keeps track of the version, okay, while regenerating a feature held back, okay, whatever. So, but what do I want to know? I'm trying to figure out what the query type. What is it? I mean, we obviously want to query faces. Okay. Okay, specifies the topological type of a given entity. Or query, or any query wait, can I just post this just in case I don't figure this out? I have the polyline showing up on the screen as well as the rectangle, which is the sweep path, as well as a rectangle sweep profile. I keep getting I feel like I'm just what is the arguments to these queries? All the faces. I mean, the thing is, I'll probably bait someone into doing this for me. What is the error, though? But honestly, it's a sick thing. So if I can just get someone to do this for me, like, it's kind of nice. But I do want to know how it works. Yeah, this is how it is. So we're just going to evaluate this. And we keep getting this stack trace. So wait, but let's do this. And I keep getting... We might have changed the code slightly, but I think that that's fine. This is the stack trace, but I don't feel familiar enough. I just say this is the stack trace. I'm just trying to, dude, they gotta hop on the freaking okay, I'm new to feature. My use case is I'm having trouble understanding how to call op sweep. Alright, I'm done. Let's just do it. After it's approved, Dude, come on, man. Okay, let's read more of those docs, I guess. We might be able to figure this out. I mean, this obviously there's a way to do this. I'm not just like, I'm just being like, I'm just pretending that this. What if I just delete the last one here? There's no way that this works. There's just no way that this changes anything. Wait. Wait, what? Oh wait, oh, I'm dumb as hell. We need to do this and we need to do this. Oh, but I deleted the feature. Wait, but it didn't error. But it didn't. Oh wait, but no, dude. Why am I so silly? Yeah, it's the same thing. So okay. Dude, someone approve my my message, because I'm so ready for this to be ready. Oh, where are my keys at? Check it out. Check it out. It's pretty cool, actually. It's like a fun geometric object. It's pretty cool. So, okay, how are they using this? That's a question. Sketch entity query. Wait. How do I get what this returns though? That's what I'm saying. That's what's so good is introspection. You should be able to. So, wait. Sketch entity query. What does this do? Hey, what's going on? Oh. What is this? Return all the wire bodies. So wait, did this work though? This is gonna be sketch 1. So it should get all of the edges. Sketch entity ID. Oh wait, this needs to be rectangle 1, and this needs to be. Oh wait, ID plus sketch 1. So honestly, I'm shooting in the dark. Okay, what is this? Returns a query. So we want to do this, and we want to say var q equals this, and then we put q here. There's just no way this thing works. Call what? Wait. What is this dot dot dot? Why is it not showing me? Oh gosh. Why isn't it showing me the whole error? Oh wait, but we want to query faces. Dude, someone gonna approve this? Bro, come on. Approve my posts. Wait, but did this? No, wait, but we couldn't find the actual code for this. We just. I don't think that this does what I want it to. Yeah, this is this totally, like. Wait, what was the code that worked? Let's try his code. Ugh. What? Oh wait. There we go. Okay. Wait, does this run? We need Part Studio. And we wanna do my feature. And this gets the sweep path failed. But what do I get? Do I get sweep path failed? I don't think I do. I think I get. Wait. Oh, where's my post, bro? Wait. I just posted something. Where is my post? Okay. But yeah, let's just figure out what it was. Okay, here it's, yeah, but let's just comment that out. What is it? Oh. Sweep select profile. What if I turn this thing on? Is this thing... Profile control mode not found. Where did I get this? What? Dude, what? Where did I even get this from? Ops sweep. Profiles. FS. Half L. How do I import this thing? What's up with this? Where is it? I have to import something? What is the... Okay, op sweep. Dude, I don't like these because they're hidden. For simple sweeps. But sweep you don't even get. I don't even know how you get sweep. Is a query. How do you make a query? What's a query? Oh, wait, can we just read this introduction? Because it's not going to be in the tutorials. It's going to be in here. And there's no search, man. Q created pi specifies geometry created during a certain operation. Q contains point specifies geometry that... How do you combine them? Okay. A query does not reference entities. It simply encodes criteria. However, when passed into a function like an evaluation or an operation, together with a context, that function can determine which entities match the query. In general, the functions you use will take care of evaluating which entities match a query. However, sometimes it is necessary to determine how many entities match a query or perform a loop over each match. Evaluation functions are used to measure the geometry. Queries are used to refer to the topological entity in a context. Evaluation functions are used to measure the geometry and topology in a context. They take a context and a map that specifies what to measure. For example, ev box 3D, ev volume respectively define the bounding box and the volume of a group Operations are standard library functions that create or modify geometry in a context. They start with op and take 3 arguments: context, ID, and a definition map. What is a definition map? A feature may have no operations, like a sign variable. One operation, like fillet, calls op fillet. Dude, what? Or multiple operations like extrude, which may call op extrude, op draft, op boolean, and more. Operations modify the context which is passed in. Sketches can be created inside of custom features as final products or as a step towards building new geometry. The typical way of creating sketches from within a feature is different from the typical way of creating sketches interactively in two important ways. When creating a sketch from featurescript, full control over the sketch coordinate system is important. The new sketch on plane function creates a sketch whose coordinate system is derived from that of the passed-in plane. Well, new sketch uses a canonical coordinate system. Sketches created from featurescript often don't need to make use of constraints, although they can if necessary, because it's often easier to calculate the desired sketch entity coordinates in featurescript than to set up the correct constraint system. Huh. But really? That's weird. Dude, no, come on. That's insane, man. Alright, but I'm tired of featurescript. I'm gonna wait on that. But I did just snap a pic. I bought this exact model about 12 months ago to use in the place of a 4 horsepower compressor that had finally bit the dust after 21 years, most of the years being left out in the weather. I need something inexpensive and right now that this fits the bill. How does a compressor actually work, dude? I don't get how they do that. Oh, dude, we don't even know if it works, bro. Okay, wait, but... Oh, wow. Okay. It would actually be cool to do like a controlled test where you make some 3D printed object and one part of it is like way thinner than another and then you get it to burst at the end. That'd be pretty cool. Calculate the appropriate thickness. Use some extension cord. How do you even use it then? The current your product will draw. Symbology. I like that word. What is SCFM? Something cubic feet meters or something? No. Oops, I need to go get some of that. Wait, can I download this thing? I'd rather just download it. Oh, this is like way better quality too. That's so crazy. $88 decibels at 1 meter. Wait, this is all assembly. I feel like I don't care. Okay, so what is this? Oh, wait. Okay, yeah. So the two most common use cases of this thing are for painting and for I'm guessing this is a nail gun. I don't really know. Impact driver or something. I don't know. Okay, so A is air hose. B is a filter. C is a regulator. Or no, C is a regulator. D is a lubricator. I don't know what that does. I don't know what that does. Coupler and plug. Oh wait, A, another hose? Dude, for real? This is how many parts you need just to use a nail gun? It doesn't even say what these are, to be honest, but whatever. Oh my gosh. Check the oil level before operation. Fill with pump crankcase 39 with premium 30 weight non-detergent air compressor oil. Running the air compressor with the incorrect amount of oil will cause damage to the equipment and void the warranty. To prevent damage, do not use with overfilled or low oil. Slowly fill to full line. Wait 2 minutes and fill back up to the full line. Compressor has small passages that will fill slowly. Okay. The oil level should be at the center of the full. Okay. Damn, that featurescript thing today. I mean, I was acting dumb, but that really threw me for a loop. It was just like so confusing. Did they even ever? I feel like it's gonna take forever, but I'm gonna forget to like check this. That's why it needs to be quick. Where is the? Wait. Where did it go? Oh, it's here. General operating instructions. Close the drain valve. Make sure all nuts and bolts are tight. Check for oil leaks and oil level. Close the inline shutoff valve between the compressor and the air hose. Make sure the air tool's throttle or switch is in the off position. Connect the air tool to the air hose. Plug the air compressor power cord into a grounded 120. Open the shut-in line. Turn the power level on. Allow the air compressor to build up pressure until it cycles off. It's interesting with more compute, you can embed more like debugging in your hardware. So like you could tell the user why it's doing what it's doing, but like when it's just sitting there, yeah, you need to put all these instructions. It's kind of cool. Okay, so how do you build a tool that uses this compressor? That's so cool, actually. Yeah, like obviously these exist. Wait, why does it have... Wouldn't you only expect it to be like... Why is it... Like this one makes sense. This blocks air from going through here. Dude, this is not so bad. You just CAD this, and wonder if we have something like this. I feel like we might. It's in standard. Dude, I've been watching videos about AliExpress, bro. What? Why is it in French? Bro, what the hell is going on? Wait, why am I in France? I need to do that. Okay, so let's look for a... wait. Dude, why is it in France? Let's change this freaking... Hundred Palms? Is that the city? Oh my gosh, dude, this thing is such a clusterfuck, dude. What the hell? We just want a one... what is the general name for this? Solenoid valve. That's what you want. You want solenoid valve. Yeah, no, we want a normally closed one for sure. For water, oil, helium, gas. Do these say their pressure ratings? Wait, what if we just Google solenoid valve on a site that I understand? Quarter-inch, two-way, normally closed electronic stainless steel. I feel like all of these should have their pressure rating, right? Like, how can you use this if you can't say what its pressure rating is? Wait, what's a... Okay, wait, help me understand. Is this enough information to tell if it can handle 125 psi? Wait. Oh my god. Dude, this is fucking... Oh, I see what's happening. Okay, but it's $10. And when do I get it? It's crazy that... What does IP mean? That's not that much current. Dude, my solenoid takes, like, so much current. Oh, cool. Okay, yeah, that's cool. Oh, yeah, IP. Ingress protection. Alright. Best match. water. Okay, dude, these 24 volts, we can't really use that. Dude, that's insane that they have no specification of its pressure. All these, I mean, it was 99 cents. Welcome deal. Dude, this shit is insane. For water. Yeah, we don't want to control water. What to search for to find the solenoid I need. It's going to come up with a long one, but how do I specify that I want one for air? A lot of the ones I'm seeing are for water. Air solenoid valve, obviously. Okay, yeah, see, this looks kind of like the package I was expecting. This is my welcome deal. Wait, what are these? Quarter-inch. This is for the fittings. 12 volts DC. Great customer support. What? Dude, how do you know what PSI I can take? I'm so baffled that... Don't you need to know that? Dude, this is so funny. Where's the pressure? What if I just Google... That's crazy, bro. Dude, AliExpress is an insane place. I'm so surprised this isn't a more common thing. What's up, bro? You probably... What's going on? It's been a while. I'm trying to dip my toes into using this air compressor I have, and I just want to. Basically, I need a solenoid. I have the relay. The thing has a pressure regulator on it. Um, yeah, and then once we have, well, we need to get the fittings for these things. I feel like I'm sort of down to get this. This thing says it can handle 100 PSI. This thing doesn't say anything. Wait, is this 12 volts? Yeah, we need a 12 volt. And then they all specify the diameter because presumably that's like how much they can let out. I love that it's the same fucking picture, bro. It's like they put no work into selling their shit. It's so funny. Normally closed is definitely what you want, right? Because that means that, wait, for normally closed, a normally closed one means that it doesn't draw power when the valve is sealed. So no airflow, no current. Then when you attach the current, airflow. Okay, yeah. That's insane that none of these have PSI specifications. Where is this part that I'm trying to get most used? Okay, so I mean, you could fit the, well, let's look at this one. So this one's threaded on the inside. So I'm trying to figure out. Yeah, they use a totally different threading system. I've read about that. I've heard about that. Dude, it's $10. Should I just buy this thing? Wait, when does it come? Oh, it doesn't say. It's weird that most of these take 120. Let's look up a YouTube video about solenoid valves. I mean, it's literally just a solenoid that seals it. It's like not that hard, but
Hey there guys, Paul here from engineeringmindset.com. In this video, we're going to be learning the basics of how solenoid valves work. Coming up, what do they look like, why are they used, where are they used, and how do they work? If you are working with solenoid valves, you're going to want to download properly look about them. As you would expect, they have the valve body, but on the top they have a block which will have some cables coming out once the valve is installed. This top part is the solenoid and the bottom part is the valve, therefore making a solenoid valve. Here's a small real-world solenoid valve, and in the next solenoid video, we're going to actually cut this one open to look inside, as well as make a very simple solenoid valve ourselves to understand the mechanics of how it operates. Now, these valves do come in a variety of shapes and sizes. I'll just show you some examples here. The shape variation depends on the capacity of the valves, the pressure it's working with, and the different internal mechanisms, which we'll look at later on in this video. Why do we use solenoid valves? Well, these valves allow engineers to autonomously and remotely control the flow of fluid within a system. This fluid can be a liquid or a gas, for example, water, air, natural gas, oil, steam, refrigerant, etc. The list goes on and on. The solenoid coil on the top is used to operate the valve by passing an electrical current through it to create an electromagnetic field and operate the valve. This means if it is connected to a controller, it can be operated autonomously and remotely by a computer without the need for engineers to physically run around opening and closing valves. This allows systems to run much more efficiently and safely. So where do we use or find solenoid valves? The short answer is everywhere. Solenoid valves can be found in everything from washing machines up to space rockets, although we're going to focus on the industrial and HVAC applications for this video. Let's have a look at some examples. In commercial refrigeration systems, we're almost certainly going to find at least one solenoid valve in the system, and it's usually found in the liquid line near the expansion valve. We've also covered how expansion valves work in a previous video. Do check that out, links are in the video description below. You can see this example here from an air handling unit which I was recently working on. This has a double direct expansion cooling coil inside to control the temperature of the air being sent around the building. The top expansion valve and cooling coil is always on when the system operates. But the second expansion valve and cooling coil only come on in the summer when the cooling load is too large for the single coil to handle. The solenoid valve is therefore used here to isolate the second coil and the expansion valve until it is needed. The controller then sends a signal to the valve to open and provide the additional cooling. Another very common application for solenoid valves in refrigeration systems is in the hot gas defrost line to control the flow of hot refrigerant into the evaporator during the defrost cycle. When the moisture in the air condenses on the tubes of the evaporator, it will freeze and cause a buildup of ice. We need to remove this to ensure efficient operation, so we open the solenoid valve to send hot refrigerant from the compressor through the evaporator instead of the condenser. Then, once the defrost has completed, the solenoid valve shuts and the system continues as normal in cooling mode. In industrial applications, we can use these valves to precisely control the flow and mixing of fluids. For example, to pour a perfect amount of fizzy drink into a bottle on a production line. We might also find solenoid valves being used in a production line to detect and prevent leaks. If a sensor detects a leak from the pipework, then the controller will tell the solenoid valve to close to shut that part of the production line off and prevent product being wasted, and also protect the manufacturing equipment until engineers can get there and fix it. So how do they work? As we saw earlier in the video, there are a few variations in how the valve operates depending on the required capacity and the pressures it's working with. We're going to focus on the directly operated valves, which is the simplest version. With the direct operated valve, we have the solenoid on top, which is basically a coil of wire. As you may have seen in our electrical videos, when you pass an electrical current through a coil, we generate an electromagnetic field. This magnetic field is what we'll use to control the valve. We have two types of valve, the normally open and the normally closed type. Let's look at the normally closed type first.
I mean, what I want to know is basically how do you calculate the parameters of it so that you know how much pressure you can handle.
So inside the valve we have the armature. The solenoid is placed over this and completely surrounds the armature so that it's at the center of the magnetic field. Inside the cylinder of the armature is the plunger and spring. The spring pushes the plunger down in a normally closed type valve. Because the plunger is pushed by the spring, it will sit in a down position to close the valve indefinitely. But if the coil receives an electrical current, then it will generate an electromagnetic field, and this magnetic field passes through the plunger and will cause it to move upwards against the spring, therefore opening the valve. At the center of the coil, the magnetic...
So yeah, the main issue is that you need to be very fast. You need it to quickly open, otherwise it's going to like shoot it out real slowly. So that's not going to work.
Magnetic field.
Dude, did they ever like onshape forms? Dude, I want someone to solve my problem. I do not like featurescript. You need to get some of this oil. How hard could this be, dude? I feel like the main thing is I just need to get a small rod, but connecting the, yeah, it's just going to be the connectors.
Most compact and therefore the strongest. This is why we place the plunger in the center. Once the electrical current is stopped, and the magnetic field disappears, and the spring will force the plunger down again to close the valve. With normally open valves, we again have the coil sitting around the armature, but this time the spring pushes the plunger in an upwards position so that the valve...
Yeah, like for this, I would much rather pay for a more powerful solenoid to better control the release of air. Because I could totally see that I buy a cheap one and it just doesn't go anywhere. That's how this thing always goes, bro. You're never up to spec.
Open unless the solenoid coil is powered on. There are a few different designs, but one of the simplest to understand is if we pass a current through the coil in the opposite direction, it again creates an electromagnetic field, but this time the field pushes the plunger instead of pulling it. When the plunger is pushed, it will close the valve and stop the flow of fluid in the system.
Okay. Yeah, these are probably just not going to cut it. Because the thing is, I've used solenoids, bro. They're like weak as hell. Alright, I think that's it. It's dark.